In this lesson, we'll be discussing bump and displacement mapping in Corona. The scene is extremely simple. I have this simple plane named wall and an HDR image that has been applied to a cinema 4D sky to light the scene. Let's quickly discuss what is bump mapping, what is displacement mapping, and what's the difference between the two. The main difference between bump mapping and displacement mapping is that bump mapping is just an illusion that won't alter the actual surface but just changes the surface normals to add details to the surface. But displacement mapping actually changes and modifies the actual surface and vertices, and it's much more realistic compared to bump mapping. Let's take a look at these two images. The first one was done using bump mapping to add detail to the scene, and the second one was done using displacement mapping. In the case of bump mapping, you see we have some details, but if you take a look at the outline of the plane, you can see they are the exact same outline of the original object. But in our second render with displacement mapping, because we are actually modifying and generating geometry at render time, you can see the outline has changed, the shadows and GIs are correct, and we are really having a beautiful realistic wall. Bump mapping is really useful for small high frequency details like wood grain, and it is a lot faster compared to displacement mapping. But obviously displacement mapping is more suitable for getting larger alterations on our surfaces. Now let's see how we can set up bump and displacement mapping in Corona. I'm going to open up the node material editor and drag this Corona material that has been assigned to the wall. And we can start with bump mapping. If you select the Corona material and enable bump from the basic tab and head over to the bump tab, we have this bump texture slot that allows us to specify a black and white map as our map and control the strength of the bump mapping using this strength value here. So let's click on this texture button and load brick.disp.png as the bump map. The darker parts of the map gonna cause indentations and white parts are gonna cause bump. Let's start the interactive rendering and see what we get. You can clearly see how the bump mapping is using the map to alter the surface, or at least give us the illusion of alteration. Also, we have the bump strength value, which is by default set to 10%. If set to 0, there would be no bump mapping. Let's use 10. Maybe 50, 100, 200, and finally let's use 100% for now. As you can see, by increasing the value, we are just making the effect to be more pronounced and cannot, for example, expect to have 200 centimeter of change on our surface, as bump mapping is just, as I mentioned, an illusion. Now, we didn't change the height, if you wish, of the effect. We just made the illusion more pronounced, more contrasty. For now, let's disconnect this map from bump and set the strength back to 10 and start discussing displacement mapping. To perform displacement mapping in Corona, from the basic tab of the Corona material, simply enable displacement and go to the displacement tab of the Corona material. We simply define a displacement map in a displacement texture section. We then control the amount of displacement mapping using these min and max levels. And to control the overall quality of the displacement mapping and how much detail you want your displaced geometry to have, you can use the displacement section under the performance tab in the render settings window. So the first thing would be to define a displacement map as our displacement texture. So let's connect the map to the displacement input of the Corona material. Perfect, and run the interactive rendering again. Now we have displaced the wall and we get this nice bricks. There are these two important values to control how much displacement mapping we want: mean level and max level. Mean level controls the black parts of the texture, basically how much the darker pixels will push the geometry in, and max level control how much the brighter pixels pull the geometry out. This is the displacement mapping that we get with max level set to 10. Now let's try 2 centimeters. Every time I'm gonna change a displacement related parameter, we need to restart the render at the time being, because Corona needs to actually calculate the displaced geometry before starting the render. Let's try 5 centimeters. And 10 centimeters. As I increase the number, you can clearly see each time we are literally displacing the object vertices more and more based on the map. Now, as I mentioned, max level is pulling out the geometry based on the brighter pixels, but if I set the max level to 0 and mean level to -5 and restart the render, now we are pushing the geometry in based on the darker pixels of the map. And if I use positive values for the mean level, like let's say +4, now we start to pull out the geometry based on the darker pixels, which gives us an inverse displacement effect that can be very useful. For now, let's set the mean level to 0 and max level to 5 and start the render. Next, we have water level, which clips the surface where the displacement map value is below the specified value here. So let's enable water level and try 1 centimeters, 2 centimeters. As we increase the water level, more geometry gets clipped away. We can disable water level for now. As I mentioned, to control how detailed the displacement mapping is, we need to go to our render settings window and under the performance tab, come down to the displacement section. In the displacement mapping process, the original mesh will be subdivided into smaller and smaller triangles. And the more and smaller triangles we have, the more detailed the displacement mapping would be, and vice versa. This screen pixel size value controls the maximum length of a sub-triangle edge. The smaller the value, the higher the quality of our displacement mapping, but at the cost of slower renders and more memory usage. If I set it to, let's say, 50 pixels and start the render, we get no defined displacement at all. Now let's set it to 20 pixels. Every time, make sure to restart the render actually. I'm gonna just slightly better. Now set it to 10. We can start to see the overall structure. Now try 4. Now the overall structure is completely defined, but the high frequency details are lacking. Let's try 2. Now we get way more details. We can probably set it to 1 pixel. And now much more details. As we decrease this value, remember we get more details, but displacement processing before starting the render would take much longer and we require more RAM. Now if I stop the render and set the screen size to something like, let's say 5 or 6 and start the production render, you notice that the displacement calculation process was less than a second, very fast, and we start the final render immediately. But if I set the screen size to, let's say, 1 pixel and start the production render again, this time the displacement calculation phase took about 6-7 seconds. So imagine if your scene was much more complex and this could turn into like 50 seconds and you would need much more RAM as well. One thing you can do to get that details without having to sacrifice memory usage and calculation time is to use bump mapping alongside displacement mapping. So you would use a screen size like 4 or 5 and rely on bump mapping for higher frequency details. If I set the screen size to, let's say, 4 pixels or let's say 5 or 6 pixels and set the render limit to 30 seconds and start the final render. So this is what we're going to get, a well-defined structure without very intricate details. I'm going to store that in the history panel and go to the material editor and connect the map to the bump input of the material as well. Now the map is connected to both the bump input and to the displacement input. And set the bump strength to 50% and let's start the render again. Now with the same calculation time, we are getting a much more detailed render. So if you have a huge scene with tons of displaced geometries, you can try this, but in this case I'm just gonna set the screen size to 1 pixels and disconnect the bump map. In case of vector displacement maps generated in 3D sculpting tools, the process is the same. Just load the map and connect it to the displacement input of the material. Let me just hide the wall geometry and unhide this small plane called ear and create a new Coronamaterial and assign it. Load this vector displacement map called ear and connect it to the displacement input and increase max level to something like 50. Now if you go to the perspective view and run the interactive rendering, just adjust the view a bit. And here you can see our ear geometry. The difference between traditional black and white displacement maps and vector displacement maps is that the traditional ones are limited to 2 directions, up and down, but vector displacement maps can alter the geometry in all directions. Let me stop the render for now and get back to our first camera and hide the ear geometry and unhide the wall. In case of normal maps, if I just create a new Coronamaterial and assign it to the wall geometry on top of the displacement material texture tag, and load this normal map, you can connect normal maps directly to the bump map input. But to use the advantages of normal maps, you need to first load a Corona normal map and connect the texture to the normal map texture input, and now connect the output of the Corona normal map to the bump input of the material. And if you start the render, you can see the normal map has been applied correctly. And obviously in the Corona normal node there are some self-explanatory features that you can explore them on your own. For now, let's stop the render and assign the brick material back to the wall. Now we need to assign a diffuse map. Load this brick diffuse map and connect it to the diffuse color input, and this should be enough. And now we can start the final render after making sure we don't have any render limits.